Now in this video I'm going to explain you how the subnets exactly differentiates, how it works, how we need to understand, how the device will understand with some couple of examples. So in the previous section we have seen some subnetting calculations where I have discussed some example. Like the first example we have seen with a requirement of 60 or 50 host addresses, and then we have used one more example with FLSM C class with a requirement of 30 hosts. So by this time I expect you to have some very good understanding on these two basic examples of the C class. We didn't do any B class or A class examples. Still we'll be getting into that more in detail in our next sections. Now the thing is we wrote some ranges, if you remember. Now I just want you to explain, I'll just explain you in this section how they differ, how they are different networks, how we need to understand more in detail. So probably I suggest you to go ahead and practice some more examples. If you want, you can go with some C class requirement of 12 host addresses. Probably you can take some time and requirement of 100 host addresses. So I want you to try these examples as an exercise for you. So here I'm going to explain you how they differ, understanding the subnets. So let me take an example. I got two computers connected to each other, and I'm using the IP address of 192.168.1.10 for one of the device, and the IP address on the second device is 192.168.1.100, and both are using the default subnet mask. Now default subnet mask means, default subnet mask means the first three portions are network and the last one portion is the host. Now my question is, do they belong to the same network or different network? So do they belong to the same network or different networks? That's my question. So now we have done some subnetting. So whenever you see the default subnet mask, which means it is not as per the subnets, which means the first three portions are network. In order to be in the same network, the network portion has to be same. Now it is same. Now we call them as same networks. Now they belong to the same networks. Okay, so let me take one more example here. So the same two devices I'm going to take, 192.168.1.10 and 192.168.1.100, but this time I'm using the subnet mask of 255, 255, 255, 192. Now I'm going to ask you the same question. So these two devices, 192.168.1.10, 192.168.1.100, they both are connected to each other, and they are using the subnet mask of 255, 255, 255, 192. Assume that I change the subnet mask, okay, to 255, 255, 255, 192. Do they belong to the same network or different network? Now after some time we generally think that it's the same networks. Actually they are in different networks. They are in different networks. That is where you need to understand subnetting. That is where you need to understand the subnets. Now they are different networks. How they are different? I'm saying that here they are same networks if I use this subnet mask, and if I use this subnet mask, I'm saying that they are in different networks. How it is possible? Let me write down some steps here. So whenever you are taking this subnet mask, whatever the subnet mask I wrote here, so how many host bits here you have? How many host bits we have in this example? 8 host bits, right? Because the first, this is network, this is network, and this is network, this is host. That's what we have learned. According to the default subnet mask, there are 8 host bits. So what is the size of the network? 2 to the power of 8. 2 to the power of h, 2 to the power of 8, the size of the network is 256. So which means the range starts from 0 and ends on 255. So which means the network ID is 0, 255 is the broadcast ID, right? The first three portions can be anything. Okay, so now here also this 10 dot and 100, they both come within this range, right? They both come in the same range. Now 10 says my network ID is 0, my broadcast ID is 255, and 100 also says the same thing. 0 is my network ID, 255 is my broadcast ID. So both are having the same network ID, broadcast ID, which means they are obviously they are in the same networks. So that's the reason I'm same networks. Okay, I agree on that. Now this is the same thing what we have learned in the basic IP addressing concepts. But if you apply the same concept in this example, how many network bits here? So to understand this example, this calculation, go back to the example 1. If you have note down some examples, go back to the example 1 with a C class with a requirement of 50 hosts. I think we did 50 hosts, right? So please check that example. In that example, just go reverse. How many host bits here? So there are 2 network bits here, which means how many host bits here? The host bits are 6 host bits. So 6 host bits means what is the size of the network? 2 to the power of 6, 2 to the power of h, nothing but 2 to the power of 6. The size of the network is how much? 64 is the size of the network. Here it is 256, here it is 64. According to 64, the range, what is the range? The range starts from 0 to 63 is one network, 64 to 127 is another network, 128 to 191, and 192 to 255. So hopefully I hope you remember. If you don't remember, let me get back to this first example which we did. The requirement of 50 hosts in the first video, and this is what the range. 0 to 63 is one network, and 64 to 127 is another network, right? That's what we did in the first example. Now coming back to the IP addresses, whatever is given here, 1.10 and 1.100. Now according to this example, the 1.10 says 1.10 comes in this range. What is the network ID? 0. And it says that any addresses coming in between 0 to 63 belongs to my network. And 1.100 comes where? 100 come here. And it says 64 is my network ID, 127 is a broadcast ID. So they are different networks, right? So they are coming in a different ranges, which means they are different networks. So whenever you change the subnet mask, now these two are different networks. That's the reason I'm saying now they are on different networks. Why? Because now in this example they are on the same networks, and the reason is because of the range. They both come within the same range, but in this case they are on different networks because of this calculation. Everything is based on subnet mask here. Whenever you change the subnet mask, automatically it will change the size of the network. It will change the range of the addresses. It will change the network ID. It will change the broadcast ID. So as long as you are using default subnet mask, everything is same. Everything is just like the default, the basic, what you have learned. But when it comes to whenever you change the subnet mask, it will change everything. So everything is based on the subnet mask here. So when you get into production networks, in the network, in the designing, we only assign the IP address, we only assign the subnet mask, and the remaining everything is calculated by the device, any networking device. So even whenever you see any device with some address 192, 168, 1.10 with a subnet mask of 255, 255, 255, 192, you need to understand that okay, the users sitting in the LAN are given the IP address in the range of 0 to 63, right? Because of this IP address and because of this range and because of this subnet mask. So that is very important for you to understand. And the network ID of this range is 192.168.1.0, and the broadcast ID is 192.168.1.63. So from here onwards, in the next examples also I'm going to write the ranges same way I did in the first example, this one, and in the same way in my second example also, this one. Now we need to understand that they all are in different networks. If I write the subnet mask of 255 in the second example, 255, 255, 255, 224, you have to understand that group of 32 bits or 32 addresses, one network. This is one network, this is not network, this is subnet network. So once we do subnetting, the network size changes, everything changes, also changes the subnet mask, but the device will understand based on the subnet mask here. So that is the important thing we need to know.